So, talking about polynomials. Polynomials, and actually our next unit, Unit 7, quadratics, makes up about 25-35% of your Regents exam. So got a couple of big units coming up right now. Polynomials definition is an expression that contains constants, variables, and exponents. So it takes those three things, constants, variables, and exponents, combines them all together, and creates what we refer to as polynomials. You've actually done a lot of work with polynomials already, but you probably haven't realized that it's a polynomial that you've been working with. So a couple of characteristics of our polynomials. You cannot divide, so no dividing by a variable. So if you have a term that ends up being divided by any variable, that makes it no longer a polynomial. Second one, variables can only have whole number exponents. So whole number exponents means it can't be a fraction, it can't be a decimal, and are whole numbers negative? No. No. So you can't have any negatives either. So your exponents can only be 0, 1, 2, 3, 4, so on and so forth. And then the last thing about our polynomials, they must have a finite number of terms. Finite means that it ends. Infinite means it would go on forever. Finite means there's a certain number of terms and it ends. So some examples of polynomials. X squared plus 3x plus 4, that makes up one polynomial. Pi by itself actually is a polynomial. We'll talk about what kind of polynomial that is. Five minus x to the 11th would be a polynomial. Xy to the 3rd, that would also be a polynomial. So some non-examples. 3 over x, because again, that first one you can't divide by a variable, so 3 over x, that's not a polynomial. X to the negative 3 would not be a polynomial, because again, it's not a whole number. Whole numbers can't be negative. Just like a fraction, so y to the 1/2, not a polynomial. So then x to the 1st plus x squared plus x to the 3rd plus x to the 4th, dot, dot, dot. What does this dot, dot, dot mean? Keeps going on forever. So that means it's an infinite, and it has to be finite. You have to have only a certain number of terms. It can't keep going on forever. So we have two different ways that we can actually categorize our polynomials. So the first one is by what we refer to as the degree. So the degree is the largest exponent on a variable. Now, some degrees have special names. Once you get to a certain point, they no longer have special names. The ones that we need to know would be a degree of 0, 1, 2, 3, 4, 5, and then everything beyond that. So 6 plus, those don't have special names anymore. So a degree of 0, what that means is that there is no variable there. So an example of a polynomial that would have a degree of 0 is just simply a number. So 3 is a degree of 0. We refer to that as being constant. So if you have a polynomial with a degree of 0, it is referred to as constant. Why is it referred to as constant? Because is 3 ever going to change? It's always going to be a 3. 3 is always going to be a 3. 4 is always going to be a 4. Our next one, degree of 1. 2x plus 1 is an example of a polynomial to the first degree. It's because the exponent on my x, even though we don't write it, the exponent there on the x is a 1. So that's why it's a first degree. The largest exponent is a 1. That is known as a linear. We've done a lot of work with linears. We've graphed them, we've solved them, we've interpreted them in context, found our average rates of change, all that good stuff. So a degree of 2, x squared plus 3x minus 4 is an example of a second degree polynomial. Yes, there's two different x's there. You've got the x squared and the x to the first, but because x squared has the larger exponent, that's why it's a degree of 2. This is known as a quadratic. So we're going to be doing a lot of work with quadratics this unit and next unit. Second degree polynomial. So a third degree, an example would be x cubed minus 4. Largest exponent is a 3, so that's why it's third degree. We call that one a cubic. Third degree polynomials are cubics. Fourth degree means the largest exponent is a 4, and I changed the variable up this time because it doesn't matter what variable it is. So that's known as a quartic. Fourth degrees are quartics. So z to the fifth plus z to the third minus 1, that's an example of a fifth degree because our largest exponent is 5. That's a quintic. And then again, anything higher than 5, whatever that degree is, it's just refer to that degree. So like 6th degree, or 7th degree, or 10th degree. Whatever the largest exponent is, it's that degree. So y to the 6th minus 1, that's an example of a 6th degree. It doesn't have a special name. You just state what the number is. You got to learn those. You got to memorize those. So whatever you need to do, flashcards, just saying it over and over again, whatever helps you memorize stuff, you got to do. So our other way of categorizing them is by how many terms that they have. Terms are separated by plus and minus signs. Terms are separated by plus minus signs. So 1 term, 2 terms, 3 terms, those all have special names, but 4 or higher, they don't have any special names to it. This was on our vocab list. Anybody willing to guess what they think a 1 term is called? Monomial. Monomial. Mono, meaning 1. Monomial, 1 term. So for example, 3x is a monomial. It's part of 1 term. It's part of one term? 3x makes up the one term. Two terms is referred to as a binomial. So 4y and the 5 would be our two terms. They're separated by a plus sign there. 4y together make up the one term. 5 is our second term. Three terms is known as a trinomial. So for example, x squared minus 6x minus 9. X squared is one term. 6x is another term. 9 is a third term. And then four terms or higher are just known as polynomials. Notice, so if you have 6 terms, it's still just called a polynomial. 10 terms, it's called a polynomial. If it has 4 or more terms, we just call it polynomial. There's no special name. Let's take a look at my 3 examples over here. We are going to name these both by degree and by number of terms. So it's going to get 2 names for each one. So if we look at the first one there, we have negative 7 plus 3n to the third. So what's its name by degree? Cubic. Largest exponent is a 3, so that means it's a third degree. So it's a cubic. And then what's its name by number of terms? Binomial. 2 terms, the negative 7 and then the 3n cubed. 2 terms, so binomial. Let's try the next one, the number 5. It is a constant. And then what's its name by number of terms? Monomial. There's only one term there, number 5. It's not quintic. There's no variable. So it's a degree of 0. Then my third example there, name by degree. Quartic. And then name by number of terms. Trinomial. Quartic, because the largest degree or exponent is a 4, so it's a 4th degree. It's got 3 terms, so it's trinomial. So a couple of other little vocab things here. Standard form. Standard form means all of your like terms have been combined, which we're going to practice in a minute. And it's in order from greatest to least. So your exponents always go in order from the greatest exponent first to the smallest exponent last. And that's one of our unwritten rules of mathematics. They always want it in standard form, but they're not always going to tell you right in standard form. You just have to know. It's kind of like simplifying. You always have to simplify, but they don't tell you every single time that you need to. Degree, if you have more than one variable, so let's say, for example, I have x cubed y squared. I still have a monomial here. It's just got 2 variables. Adding those exponents together determines the degree. So this would be a 5th degree. If you have more than one variable, add the exponents together, that's the degree. All of my examples up here, we had just one variable. So that's why it was just whatever the largest one was. It doesn't show up as often where you have 2 letters together and you have to figure out the degree, but you never know what's going to happen. And then leading coefficient, you just, once you put it in standard form, the coefficient of your first term. That's all they're looking for when they ask you about the leading coefficient. All right, let's take a look at some examples. First thing we're going to do is we're going to figure out the different parts of our expression here. So looking at our first example, 3x squared, what part of that is the coefficient? 3. What part of that is the base? And what part is the exponent? 2. Second one, what's our coefficient? Our base, exponent. All right, and our third one, what's our coefficient? No. No. What's always there, but we don't write? 1. No. Because really what's happening here? That's 1 times 2 to the third. Just kind of like if I had an x to the third and I ask you what's my coefficient, you guys know, oh, that's a 1. It's the same thing even if we got a 2 over there. So then going back to this example, what's our base? 2. And then our exponent would be a 3 on that one. So the other thing we're going to be doing today is combining like terms, but in order to combine like terms, you have to first be able to identify whether two things are actually like terms. So if we take a look at my boxes down here, we're going to go through and identify whether they are like terms or are not like terms. So looking at our first one, we have 3x squared and 4xx. Are those like terms? Let's simplify it up a little bit. How could I rewrite this? 4x squared. Are they like terms? Yes. All right, B. 2a to the third and 5a to the third. Yes, those ones are a little easier to see. Those are like terms. How about C, 4x and 7y? They don't have the same letter. Because they have the same variable and the same exponent. These ones, different variables, so not like terms. So like letter D, we have 6x to the fourth, 2x to the third. No, because it's not the same exponent. One's an x to the fourth, one's an x to the third, not like terms. 3xy and 2yx. Commutative property of multiplication. I can rewrite that as 2xy. It's the same thing no matter what order it's in. And then 4a and negative 4a. Yes. They both have a variable of a, and the a's are all to the first power. So those are like terms. So then we're going to be adding polynomials. You may see a lot of different ways that people go about adding up their polynomials. It doesn't matter which way you like to do it. Some people like to go and line up each of their like terms and then add them together. Some people like to leave them in a line, kind of like our first two examples down here are. Again, it does not matter as long as you add your like terms together and you write your answers in standard form. So again, standard form just means that largest exponent goes first and then the next largest, so on and so forth until you get to your constant term. So if we look at example 1, lots of parentheses there, but let's actually take a look. Is there anything in front of this parenthesis? No. Is there anything in front of this one? You got the plus sign there, but does the plus sign change anything? No. So I'm just going to drop my parentheses. Because again, didn't do anything, so I'm going to get rid of them. Now I'm going to add my like term. So I'm going to start with my largest exponent. My largest exponent is the x squared. So negative 2x squared plus 1x squared. Actually add the numbers in front. So what's negative 2 plus 1?
Negative x.
Negative 1x squared. The x squared stays there. You just combine the numbers out in front of them. So then we have negative 5x plus 3x. Those are our next like terms. Negative 2x. Negative 5 plus 3 is where that negative 2 comes from. And then our constant terms, 1 minus 7 gives us negative 6. And again, it's in standard form. My largest exponent was first, then it was my next largest exponent, and then it was my constant. So now on this next one, I'm just going to show you a different way you could add them together. Again, some people like to like to line up their like terms. So there's my first polynomial. It was 8y squared plus 7. My second one, I'm going to put my 5y squared underneath my 8y squared. Now that's a plus 7, so I'm going to put my minus 2y over here, because I don't want to put minus 2y underneath the 7 because they're not the same term. They're not like terms. I can't add them together. So now I can add them. I can just add going down. 8 plus 5 gives me 13y squared. 7 minus 3 gives me a 4. And then I got my minus 2y there at the end. I'm not in standard form, so I just need to rearrange that and put the minus 2y before my 4. And then there's my final answer. So again, it's just a different technique that you can use to add your like terms. All right, 3 and 4, these are just two other ways that they could ask you to do the same thing that we were just doing. Find the sum of this polynomial with 4 terms and this other polynomial with 4 terms. Looks kind of messy. So this one, I like to line up my like terms. I find it to be easier on these kinds of problems personally. So there's my first polynomial, negative 2x squared y plus 4x minus 9xy squared plus 3. And then I'm going to take the second polynomial they gave me here, and I'm going to line up my like terms. So that means I got to change my order a little bit for that second polynomial. Get my 4x and my minus 2x to line up. My xy squared to line up. And again, it's sum, so we're just going to be adding them together. So negative 2 plus 3 gives us 1. So we have 1x squared y, which you can write that one if you want to, but you don't have to. 4x minus 2x will give me a plus 2x. Negative 9 plus 12 will give me a plus 3. The 12 is positive, so negative 9 plus 12 is plus 3. And then 3 minus 5, negative 2. All right, so what we should have, 4xy to the 6th minus 11x to the 4th y plus x to the 4th y to the 4th. None of those are like terms, so I can't combine any further. That's going to be our final answer for that. All right, next one we bring in perimeter, because they love to use perimeter, the concept of perimeter, as far as adding your polynomials together. Because how do you find the perimeter of any shape? Add up all your sides. So, with a rectangle though, what's true about the top and the bottom? They're the same. And the left side and the right side? Is the same. So that means my right side would also be 5x plus 2. So now we have to add them all up. 9x plus 10, 9x plus, or minus 10, 5x plus 2. Well, I mean, if you have to show work, you have to show me what you're doing. Add them all up. You wouldn't want to raise it to the second, but you could multiply them by 2, yes. So 9x plus 5x plus 5x. 28x. Negative 10 plus 2 plus 2. Negative 16. So 28x minus 16 would be the perimeter of that rectangle. So what's true about the sides of a square?
They're all the same.
All the same. So instead of writing this 4 times, we could just multiply by 4. So what would be 3 times 4? And then 4 times the 2y would give us minus 8y. So the perimeter of our square there is 12x minus 8y. Let's have you try 7 and 8. Add up the 3 sides in 7. Add up the 5 sides in 8. 2, 3, 6, 14, 15 x's. 5 minus 1 is 4, plus 2 is 6, minus 2 is 4. 15x plus 4. All right, last thing for today is subtracting polynomials. There's just one extra step, and then it's just like you're adding polynomials. So if you're subtracting polynomials, whatever comes after the subtraction sign, you just need to change the sign values, and then you add them together. So for this one, you want to make this a minus 2, and then a minus 2x. That negative sign gets distributed to both parts of that polynomial. My 5x that was out in the front, that just stays the way it is and gets brought down. Because it's got the parentheses around the polynomial, so you're subtracting the whole thing. So I got to distribute that subtraction sign to all parts of it. So now, just like we were doing with adding, 5x minus 2x gives me 3x. There's nothing to combine that minus 2 with, so it stays as minus 2. So 3x minus 2 is our final answer. Second one, again, I'm going to distribute that subtraction sign to both parts of my polynomial that comes after it. So it becomes a negative 8x and a positive 4x. Because you have to subtract the whole thing. Mm-hmm. Mm-hmm. But sometimes you don't always have to do it, especially if you got just one term. It's just subtracting the one term. It's when you've got more than one, you've got to remember to subtract both parts of it. So now, 12x squared minus 8x squared will give us 4x squared. 7x plus 4x will give us 11x. So 4x squared plus 11x. Third one, again, same idea. This subtraction sign needs to go to all 3 parts of that polynomial. So that makes it a negative x cubed, a negative 6x squared, and a negative x. Anything in front of it doesn't change. It stays the way it is, so I just drop my parentheses. So now standard form, largest exponent needs to go first. Our largest exponent would be this x cubed right here. But there's no other x cubes for me to combine it with, so it's going to stay as negative x cubed. Negative 3x squared minus 6x squared minus 9x squared. You multiplied. And then what happens with plus x and minus x? Cancels each other out. So there's our final answer. Example 4, I always like to put a little star with example 4 because this one is asked a lot and so many kids always make the same exact mistake. Subtract the first polynomial from 4x squared minus 3x minus 5. What that means is the second one goes first, and then you're subtracting the first one from it. It's like if I told you subtract 4 from 6. You would do 6 minus 4 to give you an answer of 2. You're taking 4 away from the 6. It's the same concept, only with polynomials. So the second one goes first. You subtract the first one from it. So again, same process still. I'm going to distribute my subtraction sign through, so I get negative x squared plus 2x minus 1. First one doesn't change. So now combining our like terms, 4x squared minus 1x squared will give us 3x squared. Negative 3x plus 2x, negative 1x, negative 1x. Negative 3 plus 2 is negative 1. And then negative 5 minus 1 gives us minus 6. And then our last one, they're telling us that the letter A is that trinomial right there, 4x squared minus 2x plus 3. They're then telling us that letter B is that trinomial, negative x squared plus 5x minus 1. They want us to figure out A minus B. So, what they're telling us to do here is 4x squared minus 2x plus 3. And then you're subtracting the b. They want you to substitute those values in. So again, same thing, just asked in a different way. You're still subtracting polynomials. So I'm going to distribute my subtraction sign. That makes it a positive x squared minus 5x plus 1. So 4x squared plus 1x squared. (5x squared). 4 plus 1 is 5. Negative 2x minus 5x is negative 7x. 3 plus 1